Hey guys, so this is number 6, the final question of the free response AP Calculus 2019 test. By the way, this is the first time I ever do this, so I do apologize for the bad quality. Anyway, so you are given this, and the first part is telling you to find h prime of 2. So I just wrote some stuff down on my paper there. Why is this so blurry? Oh my god, I'm sorry. Okay, there you go. And that is also given in the problem. I just rewrote it. So this question was so easy that it was hard. A lot of people, I can imagine, overthought it. So h prime of 2 is given in this little equation that we have here. It's literally just the slope, which is this 2/3. So h prime of 2 is equal to 2/3, which is the slope of the tangent line. To h at x equals to 2. So it goes back to the fact that because this right here, what was given is the tangent line to both g and h at 2, then the slope is literally that. So let's move on to part B. Part B, you have, let a be the function given by this. I'm just going to rewrite it. So a of x is equal to 3x cubed times h of x. So this is saying find a prime and a prime of 2. Okay, so I'm given a of x. I'm looking for an expression for a prime. And then finally, whenever I have it, plug in 2 into that expression. So let's do that. Let's find a prime first. So a prime of x. Well, I'm multiplying two functions, so that is the product rule. I like to do the first function first, take the derivative of the first guy, which is 9x squared. Leave the second guy alone, which in this case is h of x. You always add with product rule. Now leave the first one alone and take the derivative of the second guy. So that is an expression for a prime of x. And then finally, plug in a 2 for x. So a prime of 2 is equal to 2 squared is 4, so I'm just going to plug in 4 times h of 2 plus, all right, 2 cubed is 8 times 3 is 24 times h prime of 2. 9 times 4 is 36 times h of 2 was given in the beginning of the problem is 4. So plug in 4 here plus 24 times h prime of 2. We have it from part A, which is 2/3. And just simplify, or I'm guessing you can also leave it like that, but I'm going to go ahead and simplify. So 36 times 4 is 144 plus, so make this a fraction, multiply across, so that's 48 over 3, which is 16. So I have 144 plus 16, which should be 160. So that's part B. And then part C was asking you to, it's a little long. So part C, the function h satisfies that mess, right? So I'm gonna write it down. So I'm gonna have h of x is equal to x squared minus 4 over 1 minus f of x cubed. All right, for x is not equal to 2. It is known that the limit of that function can be evaluated using L'Hopital's rule. Use the limit of h of x as x approaches 2 to find f of 2 and f prime of 2. All right, so we have to find, for part C, we have to find f of 2 and f prime of 2. Okay, so first thing I did is try to find the limit of this function. So I have lim as x goes to 2 of h of x, which is x squared minus 4 over 1 minus f of x, all of that is cubed. Okay, so I'm gonna do direct substitution first, and I hope we get 0 over 0, or that's the goal, because we can use L'Hopital's rule. So I'm gonna do direct substitution. So 2 squared is 4, 4 minus 4 on my numerator, all over 1 minus, oh, and I forgot the cubed here. Okay, yeah, don't forget that. So I have f of 2, all of that is cubed. So 4 minus 4 is 0, so awesome. My denominator has to also be 0, because this is L'Hopital's rule. So since I already have 0 on my numerator, I'm just going to focus on the denominator. This alone right here, which I just boxed in, must be equal to 0. So that means that f of 2 must be equal to 1. Because then if I have 1 cubed, that's 1, and 1 minus 1 is 0. So I already have one answer. I have f of 2 is equal to 1. Now I just have to find f prime of 2, which is also what they want. So for that, I'm going to go ahead and apply L'Hopital's to this limit. So I would have limit of as x approaches 2. Let's apply L'Hopital's. So limit of my numerator to x, all over limit of my denominator. That's the derivative of 1 is 0, so I'm not going to do that. So I have negative 3. Leave the inside alone. Chain rule, right? So squared times derivative of the inside, f prime. Okay, so we can plug in a couple of things. So I would have well, first let's plug in this 2, direct substitution. So I would have 2 times 2 is 4 on my numerator, negative 3 f of 2 squared times f prime of 2. So I already have f prime of 2 in there. Okay, so let's continue. From the previous section, I know that this part right here, that's equal to 1, and 1 squared is 1, and 1 times negative 3 is negative 3, so I have negative 3 f prime of 2, right? But this was the whole limit, which the limit of h of x as x approaches 2. And if we do direct substitution, if we direct substitute 2 into h, we get 4, because that is what was given up here. So that means that this is equal to 4. You just have to isolate f prime of 2. You can do it a lot of different ways, but I like to just switch their spots here. So therefore I have 4 over negative 3, and I switch the 4 with the f prime. You can do cross multiplication as well. That's the long way. I just like this trick. So I have that. And these cancel as they should. So that means that f prime of 2 is equal to negative 1/3. Because there's an invisible 1 left on my numerator. So that is part C. Finally, part D. And I'm gonna do that. Oh my gosh, I'm running out of space. I'm gonna do it on the back here. No, I'll just do it right down here for part D. So it says, it is known that g of x is less than h of x for x between 1 and 3. Let k be the function satisfying this inequality for x between 1 and 3. Is k continuous at x equals to 2? Well, continuity. We have 3 conditions for continuity, so I'm going to write them down. So continuity. So conditions. Since I'm trying to see if k is continuous at 2, right? So k2 must exist. K of 2 must exist. Second condition is that the limit of k of x as x approaches 2 also exists. And finally, the third condition, the first two must equal to each other. So the limit as x approaches 2 of k of x must be equal to k of 2, right? So let's plug in things that we know. From the problem, we know that this is true right here. So I have g of x less than equal to k of x less than equal to h of x. Well, from the beginning of the problem, I know that g of x, which in this case is 2, here, I'm just going to plug it in. Let's just plug in. So again, from the beginning of the problem, I know that g of 2 and h of 2 are 4, so plug that in. And this is low-key the squeeze theorem here. Okay, so what is the only number in the world that will make this correct? Only if k of 2 is equal to 4, right? And since this is true, we also know that the limit of g of x as x approaches 2 less than equal to the limit of k of x as x approaches 2 is less than or equal to the limit of h of x as x approaches 2. And just connecting all of these concepts, we already showed that the value of k of 2 exists and is equal to 4, and the limit is also equal to 4. So I'm just going to write it down. Since the limit of k of x as x approaches 2 is equal to the value, which all of this is equal to 4, k of x is continuous at x is equal to 2. And there you go, there you have it. I'm so sorry for the recording quality, but this is my first video ever, so I'm super excited. Can't wait for my kids to see this. Bye.